O Chemsters. This is Mrs. Vandalay bringing you more O Chemster video. We have been talking about alkenes and alkynes, and yesterday we learned some nomenclature rules. And again, you may want to go back and look at them, but the double or triple bond needs to be on the lowest set of carbons. You have to think about then, naming the branches and things like that. So this sheet here, this is page 7, I believe, is all about just practice, some more practice naming them, all right? So what I would do here in problem number 1, letter A and B at least, I would draw out their structures. This is more of a condensed structural formula, so maybe, write them out, okay? Maybe that would be helpful. And then go ahead and name them. So at least do A and B for right now. And notice there's a typo for letter B. It should be CH3, not CH2. Otherwise, you can't really do it. All right, so go ahead and pause this, and when you're ready, come back and see what you did. So please do that. Practice makes perfect. All right, well, how did this structure go? All right, hopefully you got something that looks sort of like this. I left my H's out for this one. I think I put them in on some other ones. And how do I go about naming this? I'm hoping it's pretty obvious. I would go 1, 2, 3, so you get 2-bromopropene. Why did I not put a number in front of the propene? Like, why isn't it 2-bromo-1-propene? Because remember what I had said earlier, that ethene and propene do not need numbers. It has to be on the one. There's no other way to do it. All right. So what about this next one? How did you do this? Well, a little bit more difficult, maybe, maybe not. I started out here. All right. So this double bond is this double bond. And what's coming off of this carbon? I have a CH3 and a CH3. And over here, I have a CH3 and a CH3. Okay. So that's kind of what that structure looks like. All right. Now, if you drew it more linear, kind of more like what I did here, that will work. All right. So if you drew something like this, that would be fine. And then what's left to do? We still have to number them, and hopefully you numbered it this way. It really doesn't make any difference. You could number it the other way as well. So what do you end up with? I think you end up with what? 2,3-dimethyl-2-butene. Okay. Hopefully that makes sense. So what I would do then with letters C and D, take some time out, draw these structures, and I mean it, all right, and then go back and name. See how you do, all right? So when you're done, come back. Welcome back. You know what? Maybe I need to move this up here because I'm going to need some room, aren't I? So I'm going to kind of undo this, all right? There we go. All right, so I'm going to, again, start with the C double bond like this. That's these carbons here. And I'm going to put an H here and then a Cl like this, all right? And so that's this carbon with a chlorine and a hydrogen. That's this carbon with a chlorine and a hydrogen. Here's the double bond. So then I also have another hydrogen. See that? There's a hydrogen and then the other methyl group, okay? So why am I showing you like this? Well, maybe you recall from the very beginning that, oh my goodness, this is sp2 hybridization. And what is this shape of sp2? It's trigonal planar. I hope you remember that. So it really, if you look at these structures, structure determines function, by the way, it is a trigonal planar. Okay, so you can do it that way. This also works, but it doesn't show how the trigonal planar aspect goes. And now I need to number it. Well, let me ask you this. Should I put this as carbon 1? If I do, then this becomes carbon 2 and this is carbon 3. Should I do that? And the answer is no, because my double bond needs to be on the lower set. So I'm going to put my carbon 1 there and my carbon 3 here. So now the double bond is on the 1 and 2. All right. So this becomes 1-chloro-propene. Again, if it's a propene, you really don't need to put the 1 in front of the propene, all right? Well, this next one looks a little bit more complicated, doesn't it? So here is the first set of double bonds. I tell you what, I'm going to move these H's out of the way because I'm going to need a lot of room here. All right, so here is this double bond. See this? Here's the carbon, okay? Well, what is on this carbon right here? What is on this carbon right here? Well, there is a methyl group on that carbon. All right, so I'll put that here. Maybe I'll lower it down so it makes, there we go. So here is this carbon group right here. But what else? That's this methyl group. That's this group is this group. But what else is on the carbon is another carbon, all right, that is double bonded. All right, so here is this, and here's this bond like that, okay? So, oh, there it is. Again, here's my trigonal planar, okay? I don't know if you saw that. There is a hydrogen coming off of here, which makes it trigonal planar too. These are all sp2. So here is my structure. It looks like I have two double bonds, so you might be thinking it's a diene. And why am I going this direction, okay? Because we know it's a, butadiene, isn't it? There we go. Sorry, you probably just saw that. And so I want this direction. Well, what's wrong with going here? It's still 1, 3 if I put 1, 2, 3, 4, isn't it? But then if I go 1, 2, 3, this methyl group is off of the 3. I need to go left to right, so the methyl group is off of 2. The double bonds are still on 1, 3 if I go left, right, or right, left. It's where the branch is. So this becomes 2-methyl 1,3-butadiene. What I'd like you to do now is look at the next one, okay? And there is another little typo with that one. And hang on a second, I'm trying to fix something up real quick for you. And so what is my little typo? I left out a carbon, all right, because right here, put a carbon. If I did that, this carbon right here would have 6 bonds, as it turns out, if you didn't put this extra carbon in here. So please put that in here and then draw it out and then name it, okay? So pause it and see how you do. All right, well, I'm going to start here, and I have some triple bonds. Okay, here's my triple bonds. And now I have 2 more carbons off of this one. See the CH2 with a 3 on it? That's what these are. So there's some 2 hydrogens off of here and 2 hydrogens off of here. And then this is my CH3. So I did not put all the hydrogens in there. That would take too long. So how am I going to name this? Am I going to go left to right or right to left? I think you're going to notice that if you put the 1 on the right-hand carbon, then the triple bond is on the lowest set of numbers. All right, so that's what I would do there. And it becomes, well, hopefully you got 1 pentyne. All right, so what about the next one? Okay, what can you do with this one? It's a lot like one that we've already done before, if you've seen it. Okay, let me just scroll it here. And go ahead and do letter F, okay? All right, this is what I got. I got 1-methyl cyclohexane. Why is there no number in front of the cyclohexane? Because if you have 1 double bond, it is assumed that these 2 carbons are carbon 1, carbon 2. You want your branch to be on the lowest set of carbons, so it becomes 1-methyl cyclohexane. So in problem number 2, write the structural formulas for these. So why don't you pause this? Why don't you do them all right, and then when you're done, come back. All right, so when you do these, what do you do first? You always look at the end. I find this easier to draw from the name than to name from the drawing. So start with 2-pentene. Pent means 5, so the double bond is on the 2nd and 3rd carbon, correct? So that's your 2-pentene, and then I have a methyl group off the 3rd. So that's what your structure should look like, okay? How about this next one? 2-pentene again, so I start off with the exact same structure, but now what? I have a methyl group on 2, there it is, and a methyl group on, on 4, okay? And so I'll put it right here. So there's that structure. And now number 3 is 3-hexyne, so it's a triple bond, and there's no branches on it, so there's my 3-hexyne. What about the next one? All right, so I have a cyclobutene. Here's my cyclobutane. Here's my cyclobutene, and I'll make this carbon 1, carbon 2. So if I do that, I'll put a chlorine on carbon 1 and a chlorine on carbon 2. Hopefully that works out. And finally, number 5, I have a 2-chloro-1,3-butadiene. I'm going to start with at the bottom. So I have a but, which means 4. Diene, that means I have 2 double bonds on 1 and 3. And on number 2, I have a chloro. Okay, so there is that one. Let's go on to the next page and learn a few more things. So here we are in chapter 8. There's some common names, all right? These are your older names. This is before the IUPAC really got going here, and they've been around for a long, long time. So you might be able to figure out what ethylene is. Ethyl means 2 carbons, ene means double bond. So we would call this ethene, all right? But the old name is ethylene, all right? It's not too much difference, but it's not the IUPAC, is it? Now, the next one is acetylene, and that is a misnomer in a sense, all right? So the old name isn't really going to help you figure out the structure. Acetylene has a triple bond, okay? This is widely used in welding, believe it or not. Acetylene gas is. So they've had it for a long time. It burns really, really hot, but the name doesn't really help you with how the structure is. Propylene, you could probably figure out because of the propyl and then the ene. So this is not really a misnomer. It works out pretty well. And there it is. I haven't put all the, here, I'll put it over here. I put in all the H's again to show you. This is sp2. This is your trigonal planar. This, believe it or not, is a trigonal planar, and this is tetrahedral, all right? So that's why, if I can, sometimes I put the H's in just to show you those bond angles, to show you the shape, okay? And now we have some other names, all right? And we'll see these periodically throughout the unit here, not necessarily the unit, but even the entire course. And something like vinyl, all right? So for example, vinyl chloride. Well, what is vinyl? Often you will see vinyl or allele, which is the one below it, if it's a branch, okay? So here would be the branch, all right? Let me scroll down a little bit here, hang on, oopsies. There you go. So here is vinyl. So you have, again, the C double bond C, but this something's going to be on this carbon, or who knows this carbon, but you're going to have something besides a hydrogen off of the carbon. So for example, vinyl chloride. Well, here's my vinyl, and what something's going to come off of here? Well, it's going to be a chloride. So that's vinyl chloride. You might have heard of polyvinyl chloride, otherwise known as PVC. It's like a piping, isn't it? So this is the monomer. This is the basis of polyvinyl chloride. So the vinyl, again, means you have a double bond. Well, I have another one I'm just going to throw at you. So with something like this, all right, one way to name it would be what? Vinyl cyclohexane, all right? Again, this is in terms of branch, all right? And so that would be a vinyl. Again, another way of maybe saying it would be ethanol, all right? Again, the YL typically means branch, like, methyl or ethyl or something. But if it's ethanol, then this would be the branch, okay? Now, an allele is 2-propanol. And so here is my allele group, and you notice how it is numbered, all right? So it's 2-propanol. Why would they do that? Because this is where it is attached to something. So this becomes the first carbon, this is the second carbon, and this is the third carbon. This is the one furthest away from the main gig over here, all right? So that would be an allele. So for example, would be allele chloride. So here's your allele again, and what do you think is going to be right here? You guessed it, and there it is. That would be your allele chloride. So what do you think this is going to be called? Take a wild stab. If you said allele cyclohexane, you are correct, okay? So why don't you pause this and do the problems below, and when you're done, come back. That sounds like a plan. So I left out the 1-vinyl cyclopentene. So here's your cyclopentene, carbon 1, carbon 2. I put it on carbon number 1. So it's your vinyl. So I only have 2 carbons. So what is an allele cyclopropane? Here's my cyclopropane. Notice it's ANE, not ENE. And then here's my allele group off of one of those carbons. So that's it. After this, please do that worksheet. I'll see you next time. Don't wait to be great. Bye-bye.